We'll do some introductions, talk about hierarchy of availability, business continuance tools, ZVM and ZOS platform convergence, estimating the migration effort. Again, my name is Mike McIsaac. I'm now with Innovation Data Processing. I worked for a long time with some big company with a three-letter acronym. I can't remember the name. But enough about me. Do we have any innovation data processing customers in the room? Okay, great, a few. Anyone do FDRPAS on ZOS? Good. At this point, I guess most people have ZVM and Linux really in production. Does anyone have, is there any ZVM only shop? No ZOS in-house? Does anyone have LPARs that no longer have DASD wired up in the IOCDS? So ZVM only looking at a certain set of DASD that ZVM uses. Okay, okay. And I'll get back to the point on that later. All right, and I put the resources first in case we run out of time. So this presentation has been uploaded to the Share website. There are FDRPAS manuals, there's a demo, risk-free trial of the product, and my email address. And we'll have opportunities to get some rec source code also later. Okay. Real quickly, the hierarchy of availability. So start up at a high level at 50,000 feet and say, what are we as IT shops trying to work towards? And I did not come up with these terms, high availability, continuous operations, and continuous availability. That was talked about, I think, a number of times at Share over the years, maybe not recently, but in this paper by 3 IBMers. So real quick, high availability avoids unplanned outages. All right, so you want your applications to be highly available, and there are many, many tools towards achieving this. Your recovery time objective is the time that that you really guarantee after an event occurs that you'll be back up. Maybe it's 5 minutes, maybe it's an hour, maybe it's half a day. Recovery point objective is how much data you guarantee will not be lost or can be lost, right? So if you're in the financial industry, hopefully the our PO is 0, right? We cannot afford to lose any data. Continuous operations avoids planned outages. Right? It used to be that it would be fairly easy to get a window. How many shops are finding it harder to get windows to bring your ZVM systems down and your many Linux? Yes, and I've definitely seen that as a trend. We want to work really towards continuous availability, which has no planned or unplanned outages. Is working towards an RPO and an RTO of 0. Right? For example, how long or how many windows does Amazon.com or Google.com get? Like how many times are they down for an hour? Right, 0. So they have 0 RPO and RTO. Right? So what are the tools in your toolbox to achieve continuous operations? Well, resilient hardware. You know, the good news is we're at a mainframe conference, so you have the best hardware on the planet, arguably. Right? Disk local mirroring and disk replication tools. So, you know, really, I think there's at least three main vendors: IBM, Hitachi, and EMC for disk, and they each have their own set or suite of mirroring tools, and that is certainly being used for continuous operations. Resilient ZVM and Linux features, right? As Linux has matured and the distros are keeping up with the Linux kernel and the Linux developers in Berlingen, and ZVM is working along in hand with them, we have now the ability to add memory on the fly, add CPUs on the fly, add disk on the fly, okay? And that doesn't always come right out of the box working perfectly. Or let me say it does not come right out of the box working perfectly. But I've heard at this conference that many shops are making strides towards having better tools for resiliency. Okay, HA software, right, clustering, Oracle RAC, IBM WebSphere XD, IBM DB2 HADR are some examples of the ability of really the software or the application to fail over and have work towards continuous availability. Okay, and some business continuance tools. ZVM 6.2 and later has SSI and LGR, single system image, live guest relocation. Who's doing SSI today? Who's doing ZVM SSI? Okay, great. And are people doing live guest relocation? Some? Good. Good. And when you do a live guest relocation, what are you really moving on that Linux? When that Linux moves to a different LPAR or a different KEC, a different SSI member, what's actually being moved? I contend the CPU and the memory are being moved, but not the disk. So innovation FDRPAS on the ZOS side and PASVM on the ZVM side also give you the ability to move the disk. Okay? Any questions there? All right. So coming down from 50,000 feet and drilling down a little bit, let's talk about SSI and LGR very quickly. ZVM, from 6.2 and later, can be installed into really a 2, 3, or 4 member cluster. I heard talks and kind of a wish list of moving towards larger numbers, and I think I saw the number 16 and 32, and I also saw the year 2025, which was a little disappointing. But so on the wish list, I said, well, just go straight to 64 members, and then you can skip all the steps. Anyway, I digress. But right now, a 4-member cluster is the maximum number of LPARs, and I believe the model or the environment that's recommended is 2 KECs and 2 LPARs in each KEC, right? So you can service one KEC by moving the workload over to another KEC, all right, if you have the white space. And that's your SSI cluster. Live guest relocation, I call it Linux guest relocation because I believe that Linux is the only guest that is currently supported. But let's face it, Linux is probably the main reason, or not probably, it is the main reason that ZVM is being used as much as it is today, okay? Again, memory and CPU are moved but not the disk, and this can prevent planned outages, okay? And here's an SSI block diagram. There are shared DASD in the center, and right today they do have to be ECKD DASD, or at least the common volume, I believe. And then the up to 6, those are mod 3s. I think today most people are installing onto mod 9s, so it would be about 4 mod 9s per SSI member. Okay, so let's talk about FDRPASVM. Gives you the ability to non-disruptively migrate DASD on running systems, okay? How does it do that? It copies, so you specify there's a running Linux system on this source volume, you specify a target volume, and it copies the tracks. On the ZVM side, the ZOS is doing the heavy lifting, okay? That's part of the reason I'm asking the question about, do you have LPARs where there's no ZOS attached to the DASD, okay? So if you do, let us know, and we'll look at it. I can honestly say that we're looking at as a ZVM only solution, but it may be down the road. It may be very blue sky, but right now the ZVM side monitors the changes and communicates with the ZOS side, actually through the disk, right? It's with one record, the communication, because one question came up, does that work cross KEC? And you don't need any IUCV or hypersockets. The communication actually goes through the DASD. And when all tracks are copied, so you're copying 10,000 cylinders or 150,000 or so tracks, and on the first pass, let's say 1,000 tracks get modified while that copy was occurring. So those 1,000 are recopied, and then out of that 1,000, maybe there's 100 or maybe there's 50 that change. And then when it gets down, after a certain number of passes, when it gets down to a certain number of tracks, and right now that's around 300 or 20 cylinders, right? When it gets down to 20 cylinders, the disk is frozen very momentarily. The remaining tracks are copied, and then a hyperswap, a ZVM hyperswap is issued to move the disk. And ZVM and Linux are hopefully none the wiser that they just got moved. So that's the basis of it. Any questions on that? All right. It was beta tested at customer sites last year. It GA'd in January of this year. It supports every level of ZVM that IBM supports. And, the question came up, well, why would I want to move? LGR moves my CPU and my memory, but why would I want to move my disk also? And, the reality is that very often customers have to move to a larger or a new DASD array. It should be noted that it also works cross-manufacturer, because very often if you're moving from one IBM array to a larger IBM array, there are tools that work. But I don't believe there are tools that, other than this, that work cross-manufacturer. So if you're for some reason moving from one manufacturer to another on your disk, this tool will also work. Question? So the question is, were our beta customers and early adopters, did they do any movement cross-manufacturer? Yes? Okay. Okay, yes. At least one. Okay, FDRPAS functions. FDRPASVM supports moving mini disks or perm space, full pack, and dedicated or attached volumes, then smaller to larger. All right, so, and there's a asterisk there, I think, in a later chart, but I'll talk about it right now. If you're moving from smaller to larger, the only rule is, and I don't think this is an onerous rule, is that there is no other data on the larger. You're probably moving to a brand new volume. But you can't say, I'm moving from a mod 9 to a mod 27, and the top 2/3 of the mod 27 is already populated. But that would be fairly unusual. Because what happens is, now with the latest code, when the volume gets copied, say a mod 9 to a mod 27, the allocation table of cylinders assumes that the top 2/3 or whatever cylinders are free, okay? What are the functions that FDRPAS can do? What I'm talking about is a swap, which does a hyperswap at the end. But there's also a swap dump, which you could argue could be named copy, right? It just copies a volume, and then you have a duplicate. Of course, that's an issue that you now have duplicate Volseers, right? So you have to make sure you handle that. And there's a sim swap and a sim swap mon. So to simulate, before you actually do it, you might want to take a dry run and make sure everything is in order. Okay, so you can simulate both of those, and nothing actually changes. Question? Yeah, that's simulate. Yeah, that's right. All right, here's a block diagram. You see ZOS on the left side and ZVM on the right side. You see a source volume and a target volume in the middle. And of course, it's in the middle because both systems have to have access to it. The ZVM side has really two virtual machines, a CMS virtual machine, or there's a Linux virtual machine that owns that, or writing to that volume. The CMS machine has the command, it's an FDRPAS command, and the service virtual machine is the one that communicates with the ZOS side. It installs intercepts such that with a diagnose, okay, this is done with a user-defined diagnose, the default is 104. And the intercepts are installed, and the main thread communicates with the ZOS side. and informs the OS about all the changes. So that's the crux of it. Any questions there? All right, let's go into a little detail on the ZVM side. What are the requirements? You have that your service virtual machine is running FDRPAS SV. Your source volume must be online. Of course, it's being written to by that virtual machine, the Linux virtual machine. The target volume must be online and free so that the service virtual machine can attach it to itself. Yes, question? It can also be dedicated. So it's online, but not, it can be dedicated, or it can be a full pack mini disk or attached, any of those. Okay, and then the monitor is started, and you have to also monitor the same disk, the same source disk and target disk from other systems, other LPARs that also have access to that. Okay. What happens on the ZOS side? Again, it begins copying the target to the, copying the source to the target and recopies the changes. The source volume must be online and the target volume must be offline, okay? And then the real job is started with an FDRPAS JCL job, or it can be an ISPF interface. I think most customers use JCL jobs. All right, so that's the ZVM side. When you log on to the FDRPAS SV, you can look at the console and you get a fair amount of information about what's going on. You can start the FDRPAS SV automatically in like Autolog 191, or you can just start it when you need it. Either way. If you start it every time ZVM starts and it's really not doing any work, it does not consume very many resources. Okay? It's a relatively small virtual machine. All right, so here's an example of swapping RDEV 1887 to Bravo 887. So we check if the source volume is online and the target is online and free, and here they're both attached to system. Okay, so we detach Baker 887 from system and we query it again, and that's really free, right? If you did query DESD free, you would see that Bravo 887 is in there. Okay, then you issue the, let's see, access FDRPAS. Okay, so the question is, where do you run FDRPAS from? And we find it varies depending on the shops. Myself, I just like logging on to Maint, right? I don't have a personal sysadmin ID. So Maint would do link to PAS Maint 691, and you have to set the language for the parser, for the CMS parser. We can talk about that, Alan. And then you issue the FD. So this is from Maint. You could do it from PAS Maint, or you could do it from your own system admin ID. All right, any of the three work. So we say monitor type swap Baker 887. You tell it the target, but it figures out the source. Okay. And on the console, he says, I found one device, and I'm waiting for the swap to begin. Okay, now we'll go to the ZOS side. What happens on the ZOS? The volume should be online and the target volume should be offline. And this is like speaking a different language, logging onto ZOS and doing these commands. But I'm learning a little bit of ZOS, lingua. So this is the equivalent of displaying query RDEV. That's the equivalent of query RDEV, although I think the default is to show 16 devices. You can just show one. But anyway, we're showing that both the source and the target are offline, so you have to vary the target online, and the command is vary, but the order is different, right? On VM, it's online or offline is first, and then the target RDEVs are at the end. On ZOS, the UCBs are on the front, and you use a comma, not a space, right? So it's like a different language, but it works. All right. So we now have varied the source online, and we see that O means online. Okay, trust me. And then we issue a JCL job. And you remember I talked about the 4 types of operations. So I always have all 4 operations, and 3 of them are usually commented. So the asterisk is a comment for this procedure. Okay. So we're going to do a swap. Type equals full. Larger size equals okay. If I'm going to go to a larger volume, you have to say it's okay. Max tasks is 32, so it will run up to 32 of these swaps concurrently, and the last line is amount, and this is only specifying one volume, but you can have 32 or 64 or many. You can have many, and you can use wildcards here. All right? Any questions on the ZOS side? And of course, you can use ISPF panels. So a little bit of the plumbing. ZVM installs the intercepts. ZOS main task talks to VM, passes the changes, recopies the change tracks. I've talked about this. ZVM issues the hyperswap when the source and target are in sync. And voila, magically you have moved over to a new volume. On the ZVM side, you'll see on the service virtual machine, the console will talk about when it's done and give many more error messages, informational messages. Here, okay, so now we've completed the swap, okay? And now we query the source and the target. And FDR3, what is that FDR3 VM? This, I just learned. I didn't know about labels versus vol sears, right? On the track 0, record 0, or cylinder 0, there is a label, which is 4 characters, which is usually vol 1. ZOS wants to see vol 1, or it really doesn't want to bring that volume online anymore. And then the 6 characters, I want to know the person who chose 6 characters and not 8 characters, but we're stuck with that. The next 6 characters are the vol sear. So I contend that the CPFMTXA command with the subcommand of label is a misnomer. It should be vol sear, right? But anyway. So here on the source, we changed the label from vol 1 to FDR3. Okay, there's FDR1, 1 and 2 are while the copy is happening, 3 is success, and 4 is there was an error condition. Okay. So really the source will no longer come online to ZOS or really ZVM because you've changed the vol sear, unless you're referencing it by RDEV. But of course you can go back and reclip it and reset it and reuse it. Okay, but very often people are retiring it. So any questions on that? Nope. All right. So what happens on the ZOS side now that the job is complete? How many tracks were recopied? Well, see, it's a mod 9, so 10,000 cylinders. Elapsed time is 2.6 minutes. So copying a mod 9 in under 3 minutes. Performance is pretty good. Okay? And this had a lot of changes. The first time I did it with an idling Linux, only 3 tracks changed. And then I tried writing a little loop, writing to it, you know, just filling up a file. And that brought us up to 10 tracks that changed. I said, how can I really put a workload on a Linux? So I said, I know, when you install Linux, it's laying down all of the RPMs. So I started an install of Linux onto a volume, and during the middle of the install, I swapped it, and I really was expecting the, you know, the install to cough or complain or something, but again, nothing. It was moved within 3 minutes, and the install took about 15 minutes, so for the last 12 minutes, the install had no idea that it was copying to a different volume. Okay? And this is input from a customer. We also saw some very low numbers where the Linuxes were probably just idling. But this customer did have a significant workload on a Linux that got moved. Okay? So living up to in their entirety, right? The title of this presentation is Migrating Linux Guests in their entirety. So I thought I would also work with SSI or ZVM LGR. So here's what we did, and hopefully we can get a demo of this. So I start with a Linux. This is on a Linux system. So a VMCP is a CP command. So query user ID. I'm running on SSI 63B, so a 6.3 system. My query virtual 100, the 100 mini disk is where the Linux is. So mod 9, and it's on VM 189 dog and on DASD 189 dog, RDEV, right? Okay, so from that Linux, I now ping out. It doesn't matter where I'm pinging out to, I'm just pinging. And we can see that the ping times are very quick, less than a millisecond, okay? So, and I was already monitoring the target volume, so I'm going to move it to 189 echo, okay? So I start the ping, and I hop over to ZOS, and I start the swap job. I submit the JCL job, okay? And really, I did not even see a hiccup with any pings. I saw one over a millisecond, but basically it just kept pinging. So we're now, Linux is pinging, and his system is being copied to a target volume. At around ping 50, I went over to a ZVM in main. I did a VM relocate move Linux 154 from 63B to 63A. All right, now who sees a little issue with the pings there? All right, so packet 50, and then some packets were dropped, and about 5 packets were dropped, and then it picked up at 56. And this is not unexpected from VM relocate. Correct? We're not saying that we'll never drop a packet, right? And then at ping 144, so if it's 1 ping per second, approximately 144 seconds, or in this case, under 2.5 minutes, the swap job completed. I remember Linux was running on SSI 63B, on 189 dog, and now on the same Linux, 2.5 minutes later, we do a query user ID, it's on 63A. We do a query virtual 100, and it's on a new volume. So, any questions there? All right, we'll keep moving. You can give FDRPASVM a try, a risk-free trial at that URL. And we'll keep moving on to platform convergence. Some shops are ZOS-centric, and some shops are ZVM-centric, some groups. Of course, I would assume most people in this room are ZVM-centric, so you're going to want to do as much from ZVM as possible and as little on ZOS as possible. Anybody do ZVM and ZOS pretty much equally? Anyone speak both languages? Okay. Okay. That's good. So you guys would probably do the ZVM stuff from ZVM and do the ZOS stuff from ZOS, no problem. All right. So but there's a new paper on how to submit JCL jobs from ZVM. I mean, this is really nothing new. The site file type equals JES subcommand has been around for a while. So if you FTP to the ZOS FTP server, you give your credentials, and you say site file type equals JES, it kind of switches modes into a put does not mean copy a file. A put means submit a JCL job. And a get does not mean get, well, it sort of means get a file, but the question is what file to get. So put myjob.jcl and get jobid.x. So the job ID is the one that changes because that's the job number in the JES queue, all right? So I looked at doing this, and I got help from the listservs, and people said, don't reinvent the wheel. There's VMFTP, I believe. Romney White wrote it a long time ago. It's been out on the internet for a long time. And I pulled that down. And really, you give it the VMFTP command, you give it a file name, and then left paren parm, and then job name is the JCL, right? So this file has to have a file type of JCL, all right? And really, this is like a VMFTP macro, right? So you're in a VMFTP environment, and it really helped to me reinforce the address command, right? Because address means, well, what environment am I in? So here, it's address VMFTP. So if a command is given, the default is, well, I'll assume it's an FTP command, right? So if you want to give FTP subcommands, you just issue them like they're regular commands, and it will go right to the FTP server, okay? So you can open the system, include your user ID, include your password, set site file type equals JES, you put the job file, you pull the job number, so there's this output, right? There's a wildcard or a variable that gets set. So everything that the FTP server sends back is stored in the stem variable output, and then you can pull your job back. Okay, and here's a sample ZOS JCL job. It sorted the planets. It's kind of like Hello World. I was pretty proud of myself when I got it to work, you know. But anyway, we can hopefully sort the planets. And here's the output. Earth is first. We're number 1 in the sorted list of planets. And there's only 8 planets. Pluto has been rebuffed, expelled. Okay, anyway. And then I put a wrapper around a single job, so you could, if you want to submit multiple jobs, you just iterate through the list. So here's one that does the sort. Here is one that does, and when we post-process, we have a little bit of post-processing because I was looking for error messages, so that's one that works. And then no such is, there's no such job. So here's the wrapper. And if we go through these 3, I sort the planets, I run a job, and I'm searching for certain error messages. All right, so this is working towards regression testing, kicking off our regression tests on the ZVM side. And then if there's no job, you get an error. Okay. Any questions on that? Fairly basic stuff, but again, there's a new paper out there. Actually, I think it was Lionel Dyke, who I haven't seen too much, but he wrote a paper back in 1998 on this. So it's been updated 16 years later. All right, estimating the migration effort, another tool that is hopefully useful. Okay, so here's the pop quiz for ZVMers. How do I tell how many gigabytes of DASD, what command can I issue to figure out how many gigabytes of DASD is free or available on my system? Anybody? Bueller? I contend that there really is none. I mean, there's well, CalcDASD, that's what I'm going to talk about. But where I'm going down to. What I'm going down to is, well, there's query DA, or query DASD, which gives you, and then that has options, right? And there's query RDEV, which comes back with DASD, but it comes back with other devices. And there's query alloc, because query alloc map is nice to know how much. It's somewhat of a sideline, but also while you're giving me this, tell me how much spool, page, etc. is used. And of course, query DASD details is where you get the number of cylinders. I believe that's the only place where you can get the number of cylinders, because you won't know the amount of disk space until you know the number of cylinders, because I don't think there's any VM command that comes back in gigabytes, right? All right. Oh, and then what's DASD size? So this was an interesting discussion on the listserv. And I think Alan said there's mod 1s, mod 2s, mod 3s, mod 9s, and everything else is a mod A, right? So those are in bold. But there are other sizes that people use. Does anybody, we have a discussion in this, because somebody said, no, a mod 27 is 32,760 cylinders, and a mod 54 is 65,520 cylinders. It depends on your vendor and the guy who's carving out the DASD. So does anybody use these sizes? Because it always bugged me that a mod 9 times 3 did not equal 32,760, right? So is anybody using 30,051 or 60,102? Nobody. And I heard somebody call these like mod 29s, and these are like mod 58s or something. Anyway, so we chose the ones in bold which are defined. Oh, and I think it's Derming that has a mod -32K, which is 32,760. So I started going with that, and the ZOS guys did not like that. So they said no. So I came up with these small 27s and small 54s. Anyway, this is the set we went with. So CalcDASD, you can issue help. The default output is to, well, I skipped past the chart, but with CalcDASD, you can either just say CalcDASD, and the default is, well, look at all my DASD, or you can give it just a range, right? Because maybe I'm just interested in this string, or these are my sets. So you can give it an RDEV range, or you don't have to. All right. But regardless, at the end, the default is to put one line out for every DASD that it finds, and then summarize. Okay. And that's a very small system. Hopefully we'll. So I'm going to kind of blast through these so we can, then there's a short, the left parent short says, don't spit out one line of output for every DASD, just give me a summary. And then that's a RDEV range, okay? And then there's all, or did I count volumes by size? Okay. If you would like a copy of CalcDASD, please send an email to this email address, support@fdrinnovation.com. At the last conference, they said, oh, can you send it to me? I said, sure, but we would really like it to go as a formal request, and we'll send you a copy, okay? Any questions? To summarize, user testimonial. So this is from one of our early customers. The business unit requirements that rely on Linux volumes have made it very difficult for us to schedule outages. Sound familiar? To move their systems. FDRPASVM allows us to move them non-disruptively like FDRPAS does for our ZOS volumes. Okay? So benefits of FDRPASVM. FDRPAS on ZOS has a proven reliability record, has been used by over 1,700 customers over the years, supports concurrent processing of not just one volume, but many volumes by many users. You don't have to bring your ZVM or Linux systems down. Okay, resources again, and thank you.